Hello, Don Guile here. In this short video, we're going to take a look at how to schedule with a virtual pull system. Virtual pull is designed to answer the two basic scheduling questions, rate and mix. What is the rate at which we should produce, and what is the mix we should produce over the next production cycle? So we've set up a simple spreadsheet to show how that works. For more information about the background data and calculations in the spreadsheet, feel free to download the virtual pull article and simulator from our website. As you can see, the model is for 7 items, 3 of which are make to stock and 4 of which are make to order. The first step in virtual pull is to calculate supermarkets for the stock items. Then, each supermarket is totaled, giving us the maximum inventory required to maintain the flow of each item. That maximum is then expressed in weeks of inventory by dividing each supermarket by the weekly forecast. For example, on item 1, the maximum inventory is 19,980 divided by a forecast of 5,000 per week, or about 4 weeks worth of inventory. Likewise, for item 4, the maximum is 6 weeks of inventory, and for item 7, the maximum is 5 weeks of inventory. The next step will be to show the supermarkets graphically on what we call the fuel gauge. You'll see why it's called that in a minute. For item 1, we spread the 5,000 over 4 weeks. For item 4, it's 2,500 for 6 weeks. And for item 7, it's 4,000 for 5 weeks. Next, we bring in open customer order backlog. For item 2, you can see that we have customer orders for 200 due this week and 700 due in week 3. Also note for item 1, we have customer orders totaling 9,000 due in week 3. Virtual pull is designed to show visibility of spiked customer demands beyond the forecast. In any event, we now have a graphic time-phased representation of demand. The next step is to look at supply. First, let's bring in on-hand inventories. As we did this, you notice that some of the cells in the fuel gauge are now red. Red means that that requirement in that period is covered by on-hand inventory. For example, look at item 1. We have 5,000 on hand, 5,000 forecast for the first week, so the cell is red. Look at item 2. We have 950 on hand, which covers weeks 1 and 3, and so on for all items. The next step is to bring in work in process. These are items which have started in production but are not yet complete. A yellow cell in the fuel gauge area indicates that that requirement is satisfied by a total of on-hand and work in process. For example, with item 1, the 5,000 on hand covers week 1, and the 5,000 in process covers week 2. Take a look at item 4. The 8,000 on hand covers week 1, but not week 2. When the 2,500 in process is added in, week 2 is now covered. As you can see, we now have a complete graphic representation of both current demand and current supply. It's now time to set the schedule. Before we set the schedule, notice that the rate of demand is 14,200 units per week, and the production cycle, calculated in the background, is 1 week. So in order to release the next cycle's worth of material, the planner must identify the next 14,200 units to release. The planner does this by adjusting the periods to cover on the fuel gauge, 1 week, 2 weeks, 3 weeks, and so on. This tells virtual pull how far into the future to reach to satisfy requirements not already covered by on-hand and in-process inventories. So let's start by releasing enough of each item to cover the first week. Notice the total quantity to release is 0. Why? Because the first week for all items is already covered by on-hand and in-process inventories. Let's try 2 weeks of coverage. You notice that we've generated releases for items 3 and 5, sufficient to cover their requirements in week 2. You also notice the green cells in the fuel gauge. Green indicates that the total of on-hand, in-process, and the release schedule is sufficient to cover that requirement. However, a 2-week horizon generates releases for only 4,083 units. This is not enough to cover a production cycle of 1 week. Now let's go out 3 weeks. You can see now we've picked up releases for several more items. 9,000 of item 1, 2,700 of item 3, 500 of item 4, 1,383 of item 5, and 667 of item 7. And the total to be released is approximately 1 production cycle. Also notice that the mix of items to release is optimized to balance both customer order and inventory requirements and to do it within the capacity of the resource. We now have a valid release schedule. We thought it might be interesting to see what happens if we go out 4 weeks. Notice that the total release is almost 2 production cycles worth, and it's just not necessary to schedule that far ahead. Also notice, if you look at item 1, that the total supply of 24,000 now equals the total demand on the fuel gauge. We're filling the supermarket. But the question remains, how do we make sure that we don't overfill the supermarket? To test this, let's go out 5 periods. The first thing you notice is that the total release quantity is 3 cycles worth. And again, it's not necessary to schedule that far out. But also notice that the release for item 1 is still just 14,000. The total supply for item 1 is still 24,000. Virtual pull will not allow us to release beyond the horizon of the supermarket. It will not allow us to overfill the supermarket. If it did, it wouldn't be a pull system, would it? So to wrap up, the optimal coverage in our example is 3 periods. This level loads the resource, gives us the most granular mix possible, and balances all of our inventory and customer order requirements. And since it's electronic, you have a visual schedule available anywhere on your network without the manual maintenance of Kanban cards and boards. The time it took to set our schedule was mere seconds. With virtual pull, hundreds or even thousands of items can be pull scheduled in minutes. We would like to thank you for watching our short introduction to virtual pull scheduling. Virtual pull is both scalable and flexible. It's currently being used to schedule internal and external suppliers and to schedule strictly make-to-order operations where supermarkets are not called for. We believe no other pull system, manual or electronic, can match the effectiveness of virtual pull. We wish you luck in your pull Kanban efforts. Feel free to contact us if you have any questions or comments. Bye for now.